This changes everything, Elon Musk tweeted just moments after SpaceX's FRAM-2 crew splashed down safely in the Pacific. His words, characteristically bold, carried a weight of excitement and anticipation. FRAM-2, short for Forging a Route Around Magnetic Poles, wasn't just another space mission. It was a daring leap into a new era of exploration, sending the first humans soaring over the Earth's poles in a privately built spacecraft. Polar orbits, unlike their equatorial counterparts, offer a unique vantage point. They allow spacecraft to observe nearly the entire surface of the Earth as the planet rotates beneath them. This perspective is invaluable for scientific observation, particularly for studying the polar regions, which are experiencing the most dramatic effects of climate change. Musk's proclamation of a paradigm shift wasn't hyperbole. FRAM-2 signaled a new era where private companies, not just government agencies, could reach any point on Earth from space. This opened a world of possibilities, from enhanced Earth observation and scientific discovery to potential applications in communication and logistics. The success of FRAM-2 demonstrated the growing capabilities of private spaceflight and hinted at a future where humanity's reach into the cosmos would be driven by innovation and ambition on an unprecedented scale. FRAM-2 wasn't just a mission, it was a statement. The impossible was now within reach. To understand the significance of FRAM-2, we need to look back at the milestones that paved the way. SpaceX's achievements didn't happen overnight. They were built on a foundation of daring missions that pushed the boundaries of what was considered possible in private spaceflight. Inspiration 4, in 2021, was a pivotal moment. This mission captured the world's attention by sending the first all-civilian crew into orbit. It demonstrated that space travel could be accessible beyond the realm of professional astronauts. Then came Polaris Dawn in 2024. This mission ventured further, reaching higher altitudes than any private spaceflight before it, and conducting a series of groundbreaking scientific experiments. Polaris Dawn proved that private missions could contribute significantly to scientific understanding. FRAM-2 built on these successes, taking the next logical and challenging step. It wasn't just about reaching orbit, it was about reaching specific, strategically important orbits. The polar trajectory of FRAM-2 opened up new possibilities for Earth observation and scientific research. This mission solidified SpaceX's position as a leader in private spaceflight, not just for its technological prowess but for its ambition to push the boundaries of exploration and discovery. FRAM-2 wasn't an end goal but rather a stepping stone to a future where humanity's presence in space would be defined by boldness and innovation. The Florida coast hummed with anticipation. It was 3:37 a.m. EST on March 15, 2025. On Launch Complex 39A, the Falcon 9 rocket stood bathed in powerful floodlights. Atop it was the Crew Dragon Resilience, ready to carry its 4-person crew. As the countdown clock ticked down, the air crackled with nervous energy. The roar from the Falcon 9's engines shattered the pre-dawn quiet. A plume of fire and smoke billowed out, illuminating the darkness as the rocket ascended. Inside the Crew Dragon, the astronauts were pressed back against their restraints. As the Falcon 9 ascended, the crew felt the vibrations of the powerful engines. Section 4. Resilience soars. The crew and capsule of FRAM-2. The FRAM-2 mission wouldn't have been possible without the Crew Dragon Resilience, a spacecraft that represents the cutting edge of human spaceflight technology. Resilience, chosen for its reliability and advanced capabilities, had already proven itself on previous missions. Its sleek design, equipped with state-of-the-art life support systems, and an intuitive touchscreen interface, made it ideal for this mission. At the helm was Commander Emily Carter, a veteran astronaut with 2 ISS missions. Her calm demeanor and decisive leadership were essential for success. Beside her sat mission pilot Javier Soto, a former test pilot known for his cool head. Rounding out the crew were mission specialists Dr. Kaito Ito and Dr. Anya Volkov. Dr. Ito, a geophysicist, oversaw the mission's scientific experiments. Dr. Volkov, an engineer, ensured the smooth operation of the spacecraft's systems. This international quartet represented the pinnacle of human capability and collaboration. Section 5. Science at the Poles. Unlocking Earth's secrets from orbit. FRAM-2 wasn't just about breaking altitude records, it was about pushing the boundaries of scientific discovery. The mission's polar orbit provided a unique opportunity to study Earth's polar regions, which are particularly vulnerable to climate change, and hold crucial information about our planet's past, present, and future. One of the key experiments focused on measuring the thickness of polar ice sheets using advanced radar technology. This data is crucial for understanding the rate of ice melt and its potential impact on global sea levels. The crew also deployed a series of sensors to monitor ocean salinity and temperature, providing valuable insights into the complex interplay between the oceans and climate change. Another experiment involved taking high-resolution images of the aurora borealis in Australis, the spectacular light shows that occur near Earth's poles. These images provided scientists with unprecedented data to study the interaction between the solar wind and Earth's magnetic field. The data collected during FRAM-2's mission is a treasure trove for scientists worldwide. It's helping to refine climate models, predict future environmental changes, and deepen our understanding of the interconnected systems that govern our planet. The mission's success highlights the crucial role that private spaceflight can play in advancing scientific knowledge and addressing some of the most pressing challenges facing humanity. Section 6. Pushing Boundaries, Technological Triumphs of FRAM-2. The success of FRAM-2 was not only a testament to human courage and ingenuity, but also a showcase for cutting-edge aerospace technology. The mission pushed the boundaries of existing systems and demonstrated the effectiveness of new innovations. One of the key technological challenges was developing a navigation system that could operate accurately in the polar regions, where traditional GPS signals are weaker. SpaceX engineers overcame this obstacle by creating a hybrid navigation system that combined GPS data with inputs from star trackers and inertial measurement units. This innovative solution ensured precise positioning and guidance throughout the mission. Another challenge was managing the extreme temperatures encountered during the polar orbit. The spacecraft experienced prolonged periods of both intense sunlight and frigid darkness as it circled the poles. To maintain a stable internal temperature, SpaceX developed an advanced thermal control system that utilized a combination of insulation, heat exchangers, and strategically positioned radiators. The mission also relied heavily on advanced communication systems to maintain contact with mission control, as resilience traveled over the poles, where ground stations are scarce. SpaceX utilized a network of relay satellites and ground stations strategically positioned around the globe to ensure continuous communication throughout the mission. Section 7. A Polar Pathway, FRAM-2, and the Future of Space Exploration. The successful completion of the FRAM-2 mission marks a pivotal moment in space exploration. It has opened up new possibilities for scientific discovery and technological advancement. The polar pathway forged by FRAM-2 will serve as a roadmap for future missions. We can expect a surge in polar orbiting missions, both private and government-funded. These missions will delve deeper into the mysteries of our planet's polar regions and monitor climate change. The commercial applications of polar orbits are vast. Enhanced coverage is ideal for communication satellites, Earth observation, and space tourism. We may soon see orbiting hotels offering views of the aurora borealis. FRAM-2 is a beginning, a bold step into a future where humanity's presence in space is limited only by our imagination. As we venture further into the cosmos, the spirit of exploration embodied by missions like FRAM-2 will guide us.